Well, very well. Here we have with us an LG board that has a power supply to a DC fan. In the connection socket, we see that there are 7 pins, of which the first is the positive power of 220, then there are 2 blank spaces, and then follows negative 15 volts and the 2 signals. We are going to see then a little of the circuits to understand how they are powered. We always have to go back to tracing the tracks to always orient ourselves in the different areas of the board. We are going to use a multimeter tip to be able to mark. Let's see that here we have line and neutral. With line we cross the fuse. We follow the line. We cross a coil. We follow the track with the neutral. We cross another low-pass filter. Here we have the 2 capacitors. Here the 2 filter capacitors, and coils. We continue the route, and what we are going to find is the AC rectifier bridge, AC, DC, DC. Here we have a continuous, positive, and here we cross the 5th diode. And here we have the negative. Both will follow their path to this point. Here we have negative and here positive. Evidently, this large connection at this point is the filter capacitor, larger than the normal ones. Remember that this internal board also has to power a fan through the filter capacitor, so the filter capacitor will be larger than the normal boards. We have a 100 microfarad capacitor. Excellent. From the negative, of course, we will be powering, if we follow the tracks down, the switch, and then we will reach the transformer, which is this one. But also, from those 310, we have to go out to the fan. Here we have the negative of the fan, and from the positive also, here we are going to cross a small inductance, the small filter coil, and we reach the positive of the fan. This shows us that when the board is energized and receives the rectified voltage, it powers the switched mode power supply and powers the capacitor. The 310 to the fan automatically appear. These 310 volts, when we make a measurement with the entire equipment running and measure at these points, between positive and negative, we will find 310 always, whether or not the board is turned on, whether or not the fan is turned on. Better said, the board is on, what is not on is the air conditioner, but those 310 volts enter the fan. But the fan still doesn't work because it first needs 15 volts to power its electronic circuit and then enable the IGBTs. So let's get to that. Those 15 volts that the fan will receive through this point and this, they are received only when the fan turns on. And how does it do that? Through an optocoupler. The processor informs the optocoupler that it has to turn on and activate the 15 volts to enable the fan. That will only happen when it needs to turn on, that is, when I turn on the equipment. At that moment it will turn on and the 15 volts will be injected into it. This point, which was the information that the microprocessor has to give to the fan to tell it how much it has to turn, will also be given through an optocoupler. And this third point, which is the information that comes from the fan to the microprocessor, will also be given through an optocoupler. Always to keep the zones separate. Of course, a fan can be damaged, short-circuited, or exposed to more dust. We don't want that to affect the microprocessor. That's why optocouplers are used. If you look closely, there are 2 that have to inform from the micro to the fan, to activate the 15 and to inform how much it has to turn. And there's 1 that has to inform from the fan to the micro. That's why you're seeing that they are placed in 2 different positions. There are 2 on one side and 1 on the other. 1, 2, 3, 4, 1, 2, 3, 4, and 1, 2, 3. For maybe if we see them from the other side you will be able to understand them better. You already know where the point of the LED is. Here we have one and here another towards the fan, and here we have one from the fan. We have it marked on the board. Of course, any damage to these optocouplers or the components that surround them, which are all of these, any damage to any of these resistors, capacitors, jumpers, or transistors, which we will be learning how to solder, know its value and replace, any damage to these affects the operation of the fan. Pay attention to that detail. And one more detail, if the switched mode power supply, here we have the switch and here we have the transformer, if 15 volts are not generated from this side for it to work and activate the fan, well, we will not have the 15 volts for that, IGBT then will not work either. So any damage in this area, the fan stops working. That's why, check all of these components very carefully and, of course, follow the tracks. You will see that the tracks are very fine, and believe me, many problems are due to burned or damaged tracks. Well, this is how a fan is energized. Keeping all this in mind, later we will test the voltage with the equipment running and, at that point, you will deduce if the problem is the board or the fan. What is often what we want to know. Or maybe we have a problem in the fan, but we also want to see that the problem is not the board. You also have to know how to understand everything we explain for the measurements we are going to make. Please leave a comment if you have any questions.